Hello, Network Automation Forum members and AutoCon. My name is Rajiv Gupta, and the title of my talk today is Everything Everywhere All at Once. So, at AutoCon this year, I noticed many of us are having a very similar problem that we're all trying to solve, which is we need to know everything about all of our devices, everywhere in all of our locations, all at once on demand. So Gather is my attempt to solve this problem. And I'll just read out what Gather is. It's a simple command line utility that multiplexes the output of show commands from many devices into a single file fast. You can think of it more like a function or a verb like grep or search, sort, unique, count, add. It's not really powerful on its own as a standalone application, but it's very powerful when it's combined with other functions. Also with Gather, you can take large or small infrastructure snapshots, and it works on multiple technologies. So you can look beyond your network. You can look at firewalls, load balancers, servers, wireless controllers, APs, essentially anything you can SSH into and issue commands. So a little bit more information about Netmiko. About Gather. Gather is Netmiko wrapped in a CLI with multi-threading and output formatting. So you could think of it essentially like a giant table. Um, I add some tags, so it essentially becomes a very large data frame. So the design philosophy on with Gather is very simple. I take inspiration from the humble cockroach. Cockroaches have been around for hundreds of millions of years with one survival strategy, which is to run the other way as fast as possible. And so I take inspiration from that by trying to do one thing as fast as possible and doing the opposite of what everyone else is doing, essentially running the other way. What I try to do as fast as possible is gather information. And when I'm running the other way, I'm trying to use the most simple approach I can use to work with a complex problem. Uh, so some of the other design parts of the design philosophy is use as few lines of code as possible, make it as simple as possible, reuse other people's work if I can. So in that vein, I'm trying to use as much as the Python standard library, and I'm using Kirk Byers' Netmiko. Essentially, why reinvent the wheel? And also in this slide, I do want to point out this is essentially Netmiko wrapped, and I want to thank Kirk for creating Netmiko. I think a lot of us work with Netmiko, and I know for me at least, Netmiko is the foundation of pretty much all of the automation that I'm doing. So thank you, Kirk. So why did I create this? I think we already discussed that, but I do want to talk about the difference between complicated and complex infrastructures or machines. So complicated machines are when you have a lot of parts, but you understand all of the interactions of all the parts. A complex infrastructure is when you have a lot of parts, but there's so many parts and so many classes of variables that there's emergent properties that occur from the interactions of parts that you cannot understand. So, for example, there's classes of variables that are occurring with our infrastructure. There's not just the technological variables. There's time variables, there's decay variables, uh, there's political variables, there's training variables. So that makes a complex infrastructure. And again, I'm not trying to understand the complex infrastructure. I'm essentially just trying to gather information from it. Before we go a little further, I'll just talk a little bit about my background. I've been around for quite a while. I worked at Nortel, almost pre-internet. where we did a lot of automation with TCL and expect on a switch called the DMS 100 and DMS 250s. I don't even know if they still exist. Then I worked for Internet MCI, where the backbone was a whopping DS3 45 meg backbone. Then at Cisco, I worked in network testing, and there again we use TCL expect, and so you can kind of see how far we've come. Pretty much the library used for automation at Cisco was TCL expect, and now you see where we've gone with automation. Um, at Vertella was a local Denver ISP, and now I work for a very large. I work in operations for a large pharmaceutical company, where I do a lot of automation in my day-to-day operations, using mainly Netmiko and Gather. So let's talk a little bit about Gather. Very easy to install. Pip install go Gather. Gather-H for the help file. It's very easy to use. Gather with the username, password, a command file, and a target file. That's all you need. The command file is the list of commands you want to run. The target file is the targets you want to run those commands on. There's some variations of this. You can issue single commands or single targets, but that's essentially all there is to it. So the next, I'm going to give you a little bit bigger. This is a little bit more of the help file, and the one thing I want you to notice is I have a -OS option. There's many operating systems that you can run Gather with, so you can run it on servers, firewalls, many other things, like I've said before. And essentially, this is exposing Netmiko's functionality. It's not my functionality. I'm just uh, opening up what Kirk has already created. The other thing that's very important is there is a datetime tag, so you can tag all your information with the dates and times, so you can put it into a time series database. You can throw it into a Grafana database. And there's also a no tag option, which takes everything, instead of putting into one file, it takes each device and puts it in its own specific file. That's great for backing up configs. So next, we're going to just take a quick look at, do a quick demo. We're going to do a show running and show version of about 450 devices. And you can see how simple the command is. Gather-U, the password, gather-U, the username, -p, the password, the target file, and the command file. And the command file you see here is show version, show running. And there's 453 devices. So let's just see a quick view of how quick this is. Takes about, say, 40 seconds. I'm not going to show you the whole thing. So next, we're going to take a look. So next, we're going to take a look at a little bit of a larger database. And this is what I do usually once a week or every few weeks. I have about 60 commands that I've found very useful. I run it and I take essentially a snapshot of my entire infrastructure, all of the configurations and all of the states. Again, so it's 60 commands and it's about 450 devices. It takes about five minutes to run, and it's about 10 million lines in this specific case. But again, you can run this on anything. You can run on one device or 2,000 devices. So you see, it's pretty quick. It's something that is not, it's fast enough that it's something you won't dread running. So what happens when you create a Gather database? You essentially take very large infrastructure, and in the past, you needed separate documents to understand all of the links, what they're connected to, all of the devices, what OS types they are, what device types they are, what vendor types they are, what serial numbers they're using. But after you run gather, it's all in one file. You no longer need to remember any of this, or you no longer need to refer to static documentation. You can run this whenever you're on call, once a week, and everything is stored in one file in a searchable file. So let's take a look at the gather database. It's very simple. It's just a text file. And what is it? It's all of the command outputs that are tagged with the commands that you issued, ta tagged with the device name. So as we can see, every single line has the full context for you to understand exactly where you are and what the line means. So before we talk about what you can do with this simple tagged file or a very large data frame, I'm going to just talk about, again, the Unix paradigm. The Unix paradigm is to work with small functional utilities and combine them, very simple small utilities, and combine them to create complex operations. It's not, Unix specifically does not build large monolithic applications. It's very small utilities that work together. So in this case, these are the ones I work with about 10 functions. And the reason I'm telling you about these 10 functions is I feel like they're useful. But again, this is a text file. You don't have to use any of these. You can use your own way to search. Uh, so I'll just go through them: gathering data, observing data, searching, counting, sorting, finding unique elements, formatting text, column formatting. So these are the ones I work with, but really to get started, what's extremely valuable and probably what you're going to get 80% of the benefit of is just gathering data and searching it. And I also put observing data in there because this file is so accessible because it's text. You can actually just scroll through the data yourself. And as you're looking through the data, you might find interesting things. For example, as you're looking through, you might see the word faulty in there, and then you'll realize it's associated with show power supply or show environment. And while you're doing that, you'll wonder, okay, well, what else is faulty? So then you can actually do a search for faulty, and you'll find every single power supply that's faulty in one simple search. So I think it's very important to remember what you should focus on, at least to start with, is gathering data and searching, and then somewhere in there you can actually just take a look at the file. This is just a slide that I just want to point out. Combining functions together to create complex operations the idea of that has been around very long. It's actually been around before Unix and even almost before the imperative programming style. There's a whole field of study called combinatory logic or lambda calculus that you can look into more. It's fascinating. So now let's look at what we can do. I'm going to start going through some simple examples of what I can do, but you can search any way you want, or you can use the Gather database any way you want because it's a text file. So let's just find a MAC address. So in my large database, I had the output of a show MAC. So I search for the output of the show MAC, and and then I add the specific MAC address. In this case, just to be anonymized, I just call the MAC address XXXX. So that will immediately just find every single instance of that MAC address, and it's going to tell you where the device is, the name of the device, and it's going to also tell you what command you issued. So we're going to move up complexity a little bit the next slide. So the next slide, we can actually search across time because the Gather database is taken at an instant in time, and it's also automatically, if you don't override it, it's automatically tagged with the date and the time. So we can search many Gather databases. If we do the same command, same search across multiple Gather databases, we'll see exactly when that MAC address appeared. and when it was not, when it didn't appear. So now you can search over time with no added extra complexity. So the next example, where with the no tag option that I described earlier, where using no tag, you gather data except you put it in device specific files. And like I said, it's a very good and fast way to back up all of your network configurations. But in this case, you can back them up before you make a change, then back them up after you make a change, and then just simply do a git diff, and you quickly see exactly what changes were made. Basically, you can audit your changes. So the next, we're going to move up the complexity scale slightly. So now I'm going to start to combine more functions. So the last example you saw, I combined gather with actually another application, Git. So in this case, I'm going to combine the gather, the search function with the count function. So I'm going to search for the show interface and how many are connected, and then I'm going to count the result. That's going to tell me how many interfaces I have total on my campus that are connected. If I want to go, then the next step, if I want to see everything, all of my interfaces, I look for all of the states of my interfaces on the show interface status command, and then I also can count that. So now we can go one step further. If I search show interface and how many are connected, remember the first column is the device names. So I could just literally count how many times each device name appears, and that is the number of ports that are connected on each device. So you see how you can quickly create a lot of complex queries. And now the next thing I'm going to do, is we're going to do a much more complicated example. And so in this case, we're going to find every port on your campus with a wireless AP connected to it, and then configure that AP name on the port description. So this is going to be a very complicated query and conversion into actual device configurations. Before I tell you how I do it, I want to talk to you about a concept called REPL-driven development. And I summarize REPL-driven development by saying it's ready, fire, aim, which is essentially you don't necessarily know what the end result is going to look like, but you know that you make a move. In this case, you gather and search data, and then you see what to do next. And then you can make the next move. So you do something, assess, and repeat. So in this case, the first thing we do is we search for access points in the CDP neighbor table. And so this is what we get. And we notice something. We notice that column 1 is the device name, column 5 is the AP name, column 6 and 7 are the port names. So then we make the next move is we want to print only that information. So that was the next move. We printed only that information. But the next move we want to make is we want to convert this specific information into a configuration. So the very next move is actually it's a little bit more complicated. Again, you don't need to do this, but you'll see how simple it is. I map all of these columns to variables, and then I output those variables into a file. So we're going to take a look at that. So here, you see these are the columns, 1, 5, 6, and 7. I map them to host, AP, and port A and port B, which is basically the port. So then I convert that into a text string and append it into a file with the host name prepended. And remember, the host name was column 1. So that is a little complicated, but in one line, I was able to search my entire network, find all the APs, and create them as port descriptions. And that's it's different for every single device. So now this is going to be a very complicated example, but again, I don't want people to focus on the example. I'm just trying to show you what's possible. So in this case, we're going to look at a show interface status on devices, on specific network devices running a specific OS, in this case, OS 17XX, and only show me the show interface number, a show interface for modules with a specific serial number. And I'm not going to go through this one, but what I want you to see is I'm searching. I'm searching the database once to find the software version. Then I take that information and feed it back into another search of the same database, and I find the modules with the serial number. And then I feed that back and I list the show interface status of only those modules. So that's probably a complicated example, but you can see you can just keep searching the same database over and over. So hopefully I've been able to show you that if you take a very simple components, you can have very complex outputs. And so I'll just talk to you about some of these. The main ones, I won't talk to you about all of them, but the main ones that are emerging are AI and machine learning. When you can generate a very large corpus from your network with your configurations and states, the next step is very simple to embed that and vectorize that and then create a RAG application. I'm not sure if the technology is there yet. My own experiments have yielded some positive results, but not at the moment they haven't been that impressive. But I think it's more of a question of if, not when. And I think the when is only going to be a few more months. Another thing I do is I can dump neighbor tables very quickly with Gather. Hopefully you saw that in some of those examples. And then you put them into a link mapper. Like I use Cytoscape. There's ones called Gephi, some ones called Linkurious. You can put them into a link mapper and build very detailed maps of large campuses. I mean, the maps are so detailed. Every single interface is mapped. It tells you exactly what the interface is. In my maps, each node has embedded information. So like the device name, the version, the location, anything you want can be embedded inside the node. So those are some of the large things. And you can detect errors. You can check to see if your devices are config compliant. Like I said earlier, pre and post configuration verification. And when I say tokenization, I mean specifically taking small chunks of a large amounts of configs. And specifically what I mean there is configlets for Arista devices. Okay, some more emergent properties I think that happen when you use Gather or simple functions, but specifically Gather is you start to get a different confidence about your network or your infrastructure when you know that you have access to the truth, which is the exact configuration and state of all of your devices whenever you need that information. The other thing, another derivative effect that happens is you start to have an intuitive understanding of the cost of a vendor solution. So if someone comes in and tells you that they are going to map out your network and tell you all of its states, but it's going to be 300,000 or 400,000 a year, that might be valid. There might be reasons for that, but it's a different game when you understand that you can actually just do the same thing. So you start to have a different understanding of what is the value that they're bringing. They may be bringing quite a bit of value, but you're just not believing a vendor. Another thing is, I try to design this to have low cognitive demand. We're working with such complicated and complex infrastructures that any other tool or framework that is also complicated and complex is something that some people get. Some people are very good at complicated and complex, but I think personally, I think a lot of people aren't that good at complicated and complex. They just want something simple that works. And so that's hopefully I try to design Gather to be very simple. Um, it's also very useful for controller-based architectures because controller-based architectures often show you what is happening when you look. So, for example, if you have a wireless controller and you look today and it says you have 80 APs on it, and it won't tell you that yesterday you had 100 APs on it. It will only tell you that there's 80 APs functioning correctly. So this is one way that you can build static configuration and state databases so you can see that there's a difference between yesterday and today. And the last thing I kind of touched on is this is multi-technology, so you can look beyond your network. You can look at your load balancers. You can very quickly see all of your pool members and your pools and your virtual IPs and your actual infrastructure IPs, or you can look at all your firewall rules. It's very comforting to know you have access to this kind of information on demand. So what's next? I would like to refactor down to 100 lines of code from 300 lines of code. And the reason I call this out is I think it's important to always try to subtract, be become more simple, um, uh, refine your code, make it less complex. The next thing is at the moment, I have 30 simultaneous threads. If someone could help me, or if I could get this to 1,000 simultaneous threads, you essentially could do this across any infrastructure. Because when you start talking about in the millions, running, you could do 1 million devices very quickly at 1,000 simultaneous threads. So that's my goal, and hopefully I can get there. Another big one is I would love to make this an executable because I would like to be able to hand this to people who aren't automation experts and just say you can run it on your Mac or Windows PC or Linux device. So making it executable and very fast are essentially my main goals. Another is building API front end, a nice API front end. I've already built an API front end for this using Fast API, but ideally it would be a little better, and it would be using some kind of JSON versus just text surging. So that's it. Hopefully you guys got a lot out of it. These are some references. Please install it. Pip install GoGather. I have a YouTube channel that kind of goes through some examples of how quickly you can search and build reports and find information from your network. Uh, please reach out to me. There's some other references here, but please reach out to me on LinkedIn. I'd love to hear from you. I will help you. I love when I help people work with Gather or discover their network or map out their network. So please reach out to me. I'd love to talk. Thank you, and go AutoCon.
All right, I don't have a question. I have a suggestion.
Yep.
I think you should, as far as your next steps go, I would like to see it stored, maybe run on a cron job and stored in a time series database and then graphed in something like Grafana so that you have historical data not just at your point in time when you run it, but you could say, if you had somebody that said, hey, we lost, X, Y, or Z BGP neighbor here, or we lost a MAC out of our tables here, or whatever, you would have it graphed in Grafana and you'd be able to pinpoint where that change occurred instead of having to just run this and try to pick it out at that point in time.
Okay. Well, one thing I do is I push this to a repo so that anyone can download all the databases or one database. All right, thank you. All right.